Hi, welcome to video 9.5a, the alternating series test. So we're going to start with what is an alternating series. An alternating series is a series where the terms alternate between being positive and negative. And basically what that's going to look like is you're going to have a negative 1 to an n power, or negative 1 to an n plus 1, or negative 1 to an n minus 1. So, for example, if you had negative 1 to the n, obviously when you plug in 1, you'll get negative 1, but when you plug in 2, you'll get positive 1. That's an alternating series. Here's another example. And you have negative 1 to the n times 1 over n squared. Again, you have to look at the first, the lower limit of summation, because you are starting off with an odd, which means you'll start off with a negative. And then once you realize that all that's going to happen is going to be negative, positive, negative, positive, negative, positive. Same thing here. That exponent is n plus 1, so it'll be 1 plus 1, which is 2. So the first term will be positive. The next one will be 2 plus 1, which is 3. Negative 1 to the odd power is negative, and then it'll alternate after that. Okay, so the alternating series test itself, this is the book's version. I'm not too crazy about the book's version. This is the version I would like you to know. If it's an alternating series, which means it's going to look like this, negative 1 to the n or negative 1 to the n plus 1, if the ANs, not the UN, but the AN, the part that's stuck to the negative 1 to a power, if the ANs are positive and decreasing, and if the limit as n goes to infinity of that AN is 0, then by the alternating series test, we can say that the series converges. If, on the other hand, that limit does not equal 0, you don't say it's by the alternating series test that it diverges. It diverges by the nth term test. And that you will not see in any book. Okay, here's 11-36. Determine the convergence or divergence of the series. So as soon as you see this, hopefully you'll go, oh, look, it's an alternating series. So my AN is 1 over ln of n plus 1. Notice these are all going to be positive, and these will be decreasing, which I can show. AN plus 1 is 1 over the ln of n plus 1 is less than AN, which is 1 over ln n plus 1. So this here is ln of n plus 1 right here, okay? So is that true? Well, of course it's true, because the numerators are the same and this denominator is bigger than that denominator, so the value of the fraction is less. So we do have positive ANs and decreasing ANs. It is an alternating series, so we can try the alternating series test. We're going to find the limit as n goes to infinity of AN being our 1 over ln n plus 1. That gives 1 over infinity, which gives 0. Therefore, the alternating series actually converges by the alternating series test. So here's another one. Again, this is the giveaway that it's an alternating series, negative 1 to the n plus 1. Your AN is n over 3n plus 2. Obviously, that's going to be positive for all n bigger than or equal to 1. If you want to show your AN plus 1, replace those n's by n plus 1 is greater than n. I could do the cross product. That's 3n squared plus 5n plus 2 is greater than n times what ends up being 3n squared. Well, this is 3n plus 5, and then we multiply by n and get 3n squared plus 5n. Well, what happens, of course, is I can subtract 3n squared and 5n from both sides. I end up with 2 is bigger than 0, which is correct. I'm sorry. We needed to show that AN plus 1 was less than or equal to AN, and as it turns out, it's greater than, not less than. So we cannot use the alternating series test, and therefore we're going to use the nth term test. So we have the limit as n goes to infinity of AN, which is the limit as n goes to infinity of n over 3n plus 2. Again, degree of the top equals degree of the bottom leading coefficient over leading coefficient. So since that limit does not equal 0, the series diverges by the nth term test, not by the alternating series test. Okay, so here's number 36. Again, is it an alternating series? Yes, it is. Are the ANs positive? Well, the ANs are 2 over e to the n minus 1 over e to the n. The answer, of course, will be yes. This will be a lot bigger than this because it's 1 over it. Are the ANs decreasing? Well, one way to show that is to look at the derivative. So if you think of f of x as 2 over e to the x minus e to the negative x, You could rewrite that as times e to the x minus e to the negative x to the negative 1. And now I'm going to find the denominator. So it's negative 2 times e to the x minus e to the negative x to the negative 2 times the derivative of this, which will be e to the x minus e to the negative x times negative 1. So what will happen is it will be negative 2. This becomes e to the x plus e to the negative x, and this goes down, and the exponent becomes positive. And what happens is the denominator, of course, is always going to be positive because it's squared. E to the x will be positive, e to the negative x will be positive. So as it turns out, this derivative is always negative, and therefore an is decreasing. So we can apply the alternating series test. We find the limit as n goes to infinity of our an, which is 2 over e to the n minus e to the negative n. But of course, e to the negative n is 1 over e to the n. If you let n go to infinity, you have 2 over e to the infinity is infinity. E to the infinity is infinity, but 1 over infinity is 0. I end up with 2 over infinity, which is 0. So, since that limit was equal to 0, by the alternating series test, the given series is convergent. You can do an infinite series on the TI. You'll just enter it exactly as you see it, and it goes from 1 to infinity of this expression. The only thing is sometimes that'll be just too large for the calculator to handle, so you might want to change that infinity to 100 or 50 if that happens. Now, and this is a different thing, let me mark that off as a different thing. Okay, so this is a different thing right now. Okay, so, all right. If you're asked to approximate the sum, okay, that it converges to, you'll either be asked to approximate it correct to so many decimal places, or you'll be asked to use so many terms. Now, if they do ask you correct to 3 decimal places, you're going to have to realize that you need to round all the intermediate terms, to 4 decimal places, so that at the end you can round to 3. So here's an example, the one we looked at before, 4 times 2/3 to the n. Replacing n by 1, I have 4 times 2/3 to the 1, 4 times 2/3 cubed, etc. Now, obviously, you'd need a TI-34 to get these decimals, but rounding all 4 of them, all of the terms to 4 decimal places, and we're going to assume here that they've asked you to approximate the number the series converges to using the first 4 terms. So if I just use the first 4 terms, add them together, and round that to 3 decimal places, I get 8.025. Okay? In 37 through 40, approximate the series of sum of the series by using the first 6 terms. So that takes the guesswork out of it. They're telling you to use the first 6 terms. And they didn't tell you in the book, but if you look at the back of the book, you'll notice the answer is rounded to 4 decimal places, which they should tell you that, which means we're going to round each term to 5 decimal places. So it is an alternating series. So we're going to approximate the sum by finding the sum of the first 6 terms. So I replace n by 1, I get negative 1 to the 2, which is positive, times 4 over ln of 2, minus, then I replace n by 2. Of course, these are going to alternate. So, with a TI-34, 1 over ln 2 is approximately 5.77078. Again, the next one, the next one, the next one. So what will end up happening once you add and subtract all these guys, you'll get 2.70672. Round that to 4 decimal places, it is 2.707. Now what's interesting is it says approximate the sum, but it doesn't give you the sum. It tells you that the actual sum, which is the sum of all the terms, is going to be between 2.7067 minus the 7th term and 2.7067 plus the 7th term. Because you got to think about it, the term, obviously if it converges, the absolute values of the terms are getting smaller and smaller and smaller. So what's happening is if I only use the first 6 terms, I'm leaving off the 7th term, the 8th term, the 9th term, etc. So The biggest of those, because they are getting smaller and smaller as you go down the list, the biggest of those would be the 7th term. So that's why I'm saying that my actual area is going to be between the sum of the first 6 terms minus this mystery 7th term and plus this mystery 7th term.